Hello students, welcome back to the online classes. So during the pandemic, we used to engage video classes and used to watch classes on YouTube. And thereafter again the offline classes, normal classes has started. But again the situation has become slightly critical now. So again we have to depend on the video classes for few days. Let us hope for within few days everything will get normal and let us get back to the normal classes. So till then we cannot just be idle and doing nothing. So for that sake, for the sake of the examination and completion of portion, we are doing this online classes. So already in the both classes, like special batch as well as the Sunday batch, I was dealing with thermodynamics chapter, and in that one almost around 70% of the chapter is over. The remaining one is something about some derivations, and one of the topics something called heat engine. I already told you people. And in one of the classes already I have finished one derivation, and that is what I have written here. You can see there, derive the expression for work done in isothermal process. So I think in Sunday batch I have completed it, but still let me go through once again why one more batch where I didn't finish. Okay, that is why. So let us begin then. So before starting, let me just go through what and all we have discussed so far in thermodynamics. So basic studies, thermodynamic process, terms used in thermodynamic process we have discussed, correct? And thereafter different types of, that means equation regarding the first law of thermodynamics and application of that one in different process, all those we have discussed. And then today we are going to derive a derivation that is about the, suppose there is a system which is actually undergoing some changes, state change, or there is a process which is taking place, that is isothermal process. That means at constant temperature, what happens? Volume is inversely proportional to pressure. That means the piston, the system what we have imagined, that has to move up and down, something like that happens. So meanwhile, because of that movement, there will be displacement. So that is why, so there will be some work done because of the internal energy in the system. So let us see what is that. Okay, so let us consider a system now. In our system, perfectly conducting system, thereafter it's a container actually, right? And thereafter there is a piston, and suppose heat is provided to the system. Now what happens? Whatever gas which is trapped inside or contained inside the container will get heated up. So internal energy of the gas will start increasing. That is what we already discussed, correct? So now, because of this, what happens? Let us take that before applying what? Before applying the energy, let us take the pressure of this one be P1 and volume of this one be V1. And it is isothermal process. That is why it is at constant temperature. Correct. So let P1, V1 be the initial pressure and volume of the gas which is there inside the container. And next, keeping the temperature constant, what we do, we start providing the heat. To which one? To the system here. So heat is provided here. So because of that, what happens? Of course, there will be variation of volume, and pressure also will take place. So after providing heat, let us take the new pressure, let it be P2, and the volume to which it has expanded, let it be V2. And at the end of discussion of what is that first law of thermodynamics, when it is applicable for different or four types of what is that processes, thermodynamic process, we have come across work done equation. So you people know that work done, dW is equal to P into dV, correct? Because of the variation of the volume, trying to keep the pressure constant. This is actually work done equation. Now, what is the equation for Boyle's law? Boyle's law means, of course, this isothermal process will follow or obey which one? Boyle's law. And according to that, V is proportional to P, or PV is equal to constant. So we can say that according to isothermal process, correct? according to isothermal process. PV is equal to RT. Correct? Yes. That is also, we can say, ideal gas equation. That means what we are going to consider here. Here we have to consider gas trapped. So according to this equation, what we can assume is, let us take 1 mole of ideal gas. So how you have to start the derivation? Derive the expression for work done in isothermal process. Then what you have to write? Of course, I hope everyone will write the notes neatly after watching this or while watching this video. Your notes should be up to date. So when you come back to the normal classes, everything should be complete. Okay, so do not show any kind of laziness regarding the studies, because there is no exact continuity because of the pandemic. That is why, suppose your performance has become worst or low compared to your high school, means you have to wake up now. Why? Because there is no much time now. You are at the end of first PU, and I don't know, or nobody knows that how your second PU will go on. Suppose there is a rise in pandemic death rate, again there will be online classes you have to depend on. So be serious, stay home, stay safe. That is true. Along with that, be safe for your future also. That means do the self studies. Depend on yourself also. Leave your laziness. Okay, whatever. How to start now? So we have to consider 1 mole of ideal gas in a container. Let P1 V1 be the initial pressure and volume. Let it isothermally expand. Okay. Keeping temperature constant. The work done in this process, because of the change of volume by dV, is given by dW is equal to PdV. Next, according to isothermal process, we can say that PV is equal to RT. What is that actually? In isothermal process means where it obeys Boyle's law. That is what we have written. So this is actually for very less variation of volume. How much work is done? A part of work is done, dW. Next, let us write what? Therefore, total work done. Total amount of work done. In what? In expansion from where to where? From volume V1 to V2. Correct? And right now this is continuous process. So that means we have to go for the integration method. So that is why, so total means what? W is equal to, from where to where? From V1 to V2. What is that? dW. Correct? So what is dW? dW means it is V1, V2, P into dV. Correct? So next, what we are going to do is, let us take this one as equation number 1, that is ideal gas equation, which is according to the derivation. So according to that, what we can write, that is, right now pressure is there, and with respect to V we have to integrate. Correct? So with respect to volume we cannot do any kind of, what is that? Yeah, mathematical process regarding the pressure, regarding what is that? A continuous function. So similar kind of what? Variable has to be present. Limit is also regarding volume, different integration also regarding volume, but here pressure is there, so we have to replace it. So equation number 1 will help us. So that is W is also equal to, what is that? I'll write on here, since PV is equal to RT or P is equal to RT divided by V. Am I right? So let us substitute that one here in this integration equation, that is V1 to V2 and then RT divided by V into dV. Hope this is clear for you people. It's not very complex kind of derivation actually. Already this derivation including integration method I have explained you people in Newton's law of cooling explanation, correct? The derivation, yeah. Right now R means universal gas constant and T means it is temperature. In isothermal process temperature is what? Constant. That it means integration can be done for continuous function, not for constant function. So what is constant here? R and T. So we can take it outside. So W is equal to RT integration of V1 to V2 and then what is that? 1 by V into dV. And here right now integration of 1 by V dV means it is actually of the form 1 by x dx. Integration of 1 by x dx. Answer might be you might be knowing, that is log to the base e of x. Hope you remember this. Okay, I think I have discussed this one while giving some of the basic fundamental formulas in integration when we discussed Newton's law of cooling, students. If not means fine, then look at here, integration of 1 by x means dx equal to log to the base e into x. Okay, natural log it is. And let us come here, you can see here no limits are there, but here limits are there. Upper limit, lower limit we have to apply. So W is equal to RT integration of V1 V2. Okay, don't want to continue one more step. Let us directly substitute here, nothing to worry. So this is W is equal to RT integration is over. That means log to the base e of V. From where to where? V1 to V2. I have given some space here in order to show something. Some formula I have to mention there, that is why. So what is the, okay, integration is over. But here limit is there. We have to apply limit also, correct? So that means W is equal to RT, upper limit minus lower limit. That means log to the base e of V2 minus log to the base e of V1. Upper limit, lower limit, both are applied. Right now we are having what? Log to the base e of V2 minus log to the base. But there in logarithm means, I already told you people, in olden days there were no calculators. Yes or no? That means variation or multiplication, division or finding out the roots. Roots means not something like cube root of 8, not like that, any number. It was slightly difficult. That is why this logarithm has introduced for bigger scale number as well as smaller scale numbers. So there is a rule in logarithm. What is that, you know? Log to the base e of m minus log to the base e of n. If it is so, means answer is log to the base e of m by n. One of the fundamental formula in which one? Logarithm. Okay, hope you are able to see that. Okay, fine. So by applying that logarithm fundamental formula in this current equation, we get what? So W is equal to RT log to the base e of V2 by V1. This is the equation. But right now this is exponential log to the base e. That means log to the base e, okay, that it is not log e, like this. Log to the base e. Suppose you want to write that in which form? Base 10. Base 10 means which one? You people are having what? A log table or class table or mathematical table, where you can come across something called log, anti-log there. All those logarithmic values which are given in that particular book, okay, all are actually log to the base 10. That is why we have to convert that. How to convert? To convert, no, there is actually substitution, and the final thing is like this. You have to multiply by 2.303. That is actually exponential value substitution. So this becomes RT into 2.303 log to the base 10 of V2 by V1. So this is the derivation formula. So this is the equation for what? That is in terms of log to the base 10. The actual equation RT log to the base E V2 by V1. So this is actually the expression for work done. Work done in which case? Work done in case of isothermal process. Hope this is clear. There is no any confusions here. And these two are the formulas which are actually applied in this derivation. I have written at the corner. Hope it is visible and it is clear. So this is all about the derivation, and the derivation will be asked for 5 marks. Okay. Regarding, we'll see, of course, the examination is scheduled for July as of now, and we don't know what's going to happen. But keep studying, be ready always, be updated, keep a constant touch with the subject also. So if any variations are there with the syllabus or examination, all those, we will inform you in further days. And right now, actually this is 5 mark derivation. So this is how you have to write. Already the method of writing the introduction or the explanation or interpretation I have already told you people. So follow that and write down. And then I will continue something else here. You can see, because space is not there much. We people know that according to what? According to Boyle's law, P1 V1 is equal to P2 V2. That means V2 by V1 is equal to P1 by P2 also, correct? The ratio will be same. So what you can do is, after writing this equation, okay, also after writing this entire derivation in this one, then you have to write also P1 according to Boyle's law. What is that? P1 V1 equal to P2 V2. V2 by V1, P1 by P2. Correct. Then separately you write down W equal to RT 2.3. In the place of V2 by V1, what you have to write? That is P1 by P2. So this is what the another equation regarding the work done related to the pressure variation in isothermal process, students. So hope this is clear. Have a look. It is not a complicated or difficult derivation. Kind of simple derivation. Fine then. You can pause the video and you can take down the derivation, I think. So let me go for the next topic then. So this is all about derive the expression for work done in isothermal process. So first what you have to do, first consider 1 mole of ideal gas. Let P1 V1 be the initial pressure and volume. Let T be the temperature, which is constant because it is isothermal process. Then let heat is provided to the system so that the pressure and volume will vary to P2 V2. The amount of work done when there is a variation of volume by dV, you have to write, okay, is given by dW is equal to P into dV. According to isothermal process, we know what is that? PV is equal to RT, because right now we have taken 1 mole of ideal gas here, correct? Boyle's law, it is applicable. So PV is equal to RT we have taken. Then total work done can be given by total sum of small work done, right? So from where to where? V1 to V2 dW. But what is dW? P into dV. Then apply what is that? We know PV is equal to RT. So P is equal to what? RT by V. Because we cannot integrate a physical quantities of different, what is that? Characteristic. So dV means regarding volume. So volume only we have to integrate. That is why in terms of volume we have to arranged here 1 by V into. So applying log X, all those things has come. And hope you can understand this. What is the last thing you have to write? Comparison with the pressure. Like that we have to derive the derivation. Okay. Fine. So let me erase then. Let us go for the one more derivation, okay? That is, isothermal process is over. And the second process in thermodynamic process is, already you know that, and that is adiabatic process, correct? So adiabatic process, there also temperature, pressure, volume also varies. But thing is, there is no connection, in the sense there won't be any heat gain or loss from the system to the surrounding. Okay, so that is what we have to remember. So let us see what happens in this case. Okay, so next 5-mark derivation, and what you have to write is, derive the expression for work done in case of adiabatic process. Work done in adiabatic process. Derive the expression for work done in adiabatic process. So in adiabatic process, no. So let us see. In adiabatic process, of course, temperature variation will take place. When the compression is there, temperature increases. When expansion is there, temperature decreases. So temperature variation is there, because internal energy will be there. No, that is why. But thing is, external heat won't be supplied or gained by the system, or system also won't leave to the surrounding. So let us see. So what we have to do, you have to write down what is that. Consider 1 mole of ideal gas, correct? And then what you have to write, let 1 mole of ideal gas inside the container. Let P1, V1, T1 be the initial pressure, volume and temperature of the gas. Next what we have to do, let the gas be adiabatically expand. Let the gas be adiabatically expand, so that what happens now? So when it adiabatically expands, okay, expands, so that its new pressure and volume temperature becomes P2, V2, T2. Correct? So as there is a variation of pressure, volume and temperature has taken place, means of course there has to be some work done, because variation of volume has taken place. So what is that equation? We know that, what we know, that is work done due to the small change in volume, that is dW equal to P into dV. Correct? Yes. According to adiabatic process, according to adiabatic process, what is that? We know that PV gamma is equal to constant. Correct? PV gamma is equal to constant, or PV gamma is equal to small k, I will write constant. Correct? And now let us apply that here. That means, what is the total work done in this process? Total work done. What is that? We know that W is equal to, from where to where? Volume. We are varying volume, no? dV. So V1 to V2. What is that? That is P into, or let us write just dW. Integration of all those small amount of work done together, okay? And then we can write from the equation, that is W is equal to integration from V1 to V2, that is P into dV. But as we already know, in isothermal process only, I have told you people that while integrating, the physical quantities has to be similar physical quantities. That means with respect to what you are going to integrate, that is actually the most important thing here. So W equal to, correct, also equal to, what is that? Don't want, we'll write here. Since PV gamma equal to K, correct? So, P is equal to what? K divided by V gamma. Okay? So, we'll substitute that in the equation. Hope you can understand this. So, that is W is equal to integration from where to where? That is V1 to V2, and that is K divided by, or constant also you can write down in words, no problem. Maybe in some other books they might have given like that only, so nothing to worry here. So W is equal to K by V power gamma into dV. That is what we get now. And next, what is that? Constant. Constant means, of course, while integrating, what we have to do, let us take it as a common factor. So W is equal to K into V1, V2, 1 by V power gamma into dV is there. Okay. But right now problem is, that time in the earlier derivation 1 by x is into dx, okay fine, log ex. But right now it is 1 by v to the power is there. So we cannot apply the basic formula of which one, that log x. Okay. That is why what I do, I will take this to numerator and there will be some small variation with the sign convention of the power. So what is that? I will write down like this. This is also equal to K into V1 to V2 V power minus gamma into dV. Okay. Hope you understood. What I have done over here is, the numerator right now what is there? No, actually it was in the denominator previously. It is being taken to the numerator now. That is why the power of the which one? Not power of the sign of the power will vary. Done. Next formula I will write down. What is that formula? We know that integration of x power n is equal to x power n dx is equal to x power n plus 1 divided by n plus 1 plus c. Constant, something is there, leave it. This is actually the fundamental formula of integration. Let us apply that one here. So when you apply that one here, this becomes W is equal to, after integrating, K upper limit V2 V1. What is that? X power n plus 1. That means V power minus gamma plus 1 divided by minus gamma plus 1. Correct? Next, we can also write this in some other form. What is that? Just sign convention. That is V power 1 minus gamma divided by 1 minus gamma. Correct. This is also true. Okay. Next, what is that? These things are ready. Let us apply the limits now. After applying limit, the equation will become what? You can write like this, okay, because sufficient space is not there. I have to finish off within this now. That is why I am continuing like this. Equal to here I am writing, or else W equal to separately you could write like that in notes. So after applying here, so what we get is K into V2 1 minus gamma minus V1 1 minus gamma divided by 1 minus gamma. This is what we get. Correct? So we can take that common outside also, 1 minus gamma. So we get what? So we get W is equal to K divided by 1 minus gamma and V2 1 minus gamma minus V1 1 minus gamma. Looks very complex kind of equation, no? But it's not like that. When you go on doing, no, easily you can understand, grasp it. Okay? Yes. Next is, so let us go for the next step.